All right, so today I'm going to be talking about advanced eventing scripting techniques in PowerShell. And, my name is Matt Graeber. A little bit about myself. I'm a security guy by trade. Right now I work for Mandiant as a malware reverse engineer. So if that's the sort of thing you're interested in, then attend my next talk where I'll be talking about some cool .Net malware. I was in the Navy for 6 years, and I did some time as a contractor working on the Army Red Team, like doing pen testing. I love PowerShell. I discovered it originally for its like offensive purposes, like starting with back in 2010 when Dave Kennedy gave a talk PowerShell OMFG. That really opened my eyes to PowerShell and how it could be used, like how I could use it as a pen tester. And I've got to give a shout out to my good friend Chris Campbell, who also does a lot of offensive PowerShell stuff. He's continued to motivate me through the years to continue to write new PowerShell stuff. I'm also the creator of PowerSploit, which is a module that's up on my GitHub to aid reverse engineers and pen testers. And Joe Bialik, if you were in his talk earlier, he's contributed some amazing tools to it, so definitely recommend you check that out sometime. Real quick, what we're going to be going over is I'm going to go over pretty much every single type of event that I was able to enumerate that you can tap into with PowerShell. So we'll be using WMI events, engine events, events in .NET objects, delegates, and various types of callback functions. And then I'll briefly show some code I wrote to help you discover what kinds of events are available within PowerShell. Then I'll discuss some of the limitations of eventing in PowerShell. Real quick, raise of hands, like who uses events in PowerShell fairly often? A few people, I guess. Okay, all right. And I'll discuss ways of getting around those limitations. Then I'll ask you guys if you have any ideas on how you might be able to better leverage events. So let's jump right into it. WMI events. There's two types of events, intrinsic and extrinsic events. An intrinsic event refers to any event that occurs within the WMI data model. So whenever an object in WMI is created, deleted, modified, if a namespace is added, deleted, modified, that's an intrinsic event. So in this example here, you guys probably can't see that code very well, can you? Full screen? Full screen, yep. Okay, so just in this example here, I'm tapping into an intrinsic event. In this case, I'm interested whenever there's a new Win32 logical disk object, what I'm using that for is to detect when a USB drive is inserted. So at the bottom in the arguments, I have my query. So select all, get all instance creation events within a 5-minute or 5-second polling interval, where the target instance is a Win32 logical disk. So this would trigger if any disk was added, but what I'm interested in are logical disks that are removable. So in my script log, I check the drive type. So drive type 2 is the removable drive, and I just call write host and print out the drive info. Every WMI namespace has every one of these intrinsic events available to you. So usually, like the default WMI namespace is root SymV2. So if there was any object in there that you were interested in triggering an event on, these events are available to you. The most common ones that you'll see people using would be the instance creation event. So when an object in that namespace is created, or if one is modified, instance modification event, I'll often use the method invocation event as well. So say I'm interested in whenever someone calls the create method from the Win32 process object, because I've used that in a malicious context a number of times. So if I wanted to audit that event, then I could use the method invocation event to trace that. All right, WMI extrinsic events. Basically, those are anything that's not an intrinsic event. It's not. It doesn't refer to an object that's built into the WMI data model. So there's a bunch of these events exposed to you and built in. Some of them being like, so if you're interested in process auditing, you could register an event for the Win32 process trace or process start trace objects. If you want to get even more strict, like if you want to do module auditing, you could use the Win32 module load trace class. And you can also monitor any registry activity. So let's say as an attacker, I want to persist my payload and say drop an executable to the drive and then persist that via the run key. Well, you could use this to monitor the run key, and if anything is ever added to that registry key, then you could be alerted. So in my example here, I'm using the Win32 module load trace class, and I'm alerting to whenever a DLL is loaded into a process. Now, there's engine events. These are events that are specific to PowerShell or those triggered by whenever you call the new event commandlet. So there's 3 built-in engine events. Exiting, so when the PowerShell process exits, it triggers this event. There's on idle and workflow job start event. So there's actually some pretty cool use cases for the on idle event. Like let's say you had like a fairly processor intensive task that you only wanted to execute when someone wasn't actively using PowerShell. Then you could register that event. Now, if you've got code that doesn't really fall into the eventing model, but you want to trigger some sort of custom event, then the new event commandlet is extremely useful. You can just pass it any script block, and it'll trigger that event for you. Now, in .NET, .NET objects can also have events, and to tap into those, you would use the register object event commandlet. In this example here, I'm using the timer class, and I'm going to trigger event every 2 seconds. So what I would do to do that is specify the input object, my timer object, give the event name, which is the elapsed event, provide a unique identifier for it, just calling that timer elapsed, and then the action that I want to perform when that event triggers. So I'm just going to call write host and say time elapsed. And then you would pass all that to register object event, start your timer, and then at the bottom here is what I would do to unregister that event. All right. Now we can get a little more advanced too. Recently I ran into a limitation with register object event where I wanted to register an event for this one particular object, but it wouldn't let me do that because the event handler had a return value, so it wouldn't let me do that. So when I was working on the content for my next talk, I was interested in finding out whenever a dependency needed to be resolved for an assembly. Because one of the things I'll be doing is I'll load an assembly in a reflection-only context, which allows you to perform type introspection on that assembly without actually executing it. But .NET won't resolve any DLL dependencies by default. You have to do those yourself. So I tried to use register object event for this, but it wouldn't let me do it. So what's the solution? Brute force. So what I ended up doing here was I went to MSDN, I was like, okay, what's this assembly resolve event actually do? And what does it expect? Well, it says the resolve event handler for this event must return an assembly that satisfies the dependency. Okay, so the return type that it's expecting to see is a system.reflection.assembly class. Okay? So then continuing on, I see the resolve event handler. It takes two parameters, the sender object and resolve event args. And the return value, again, is that system.reflection.assembly class. All right, so how can I actually tap into this? This real quick.
Windows key P, and then you choose duplicate. It should be extended right now, right?
Yep. So you sorry about that. Okay, cool. Okay, so let me show you what I'm talking about. So I want to register an event for the assembly resolve event. So let's try that out. And it's going to give me that error saying that events that require return value are not supported. Let me just investigate a little bit and see what's going on with the current domain class. So I'm going to pipe the current domain object to getMember and give it the -private switch. And this is only available to through PowerShell. I wrote a proxy function for getMember so that I can see all the private members of an object. So let's check that out. And up here is that resolve event handler that I'm interested in. So it's a non-public field that hopefully, if I can set that field with my script block, then I should be able to trigger on that event. Okay, so let me set up my event handler. Here in my param block, I'm giving it the sender and the resolve args, which is what the resolve event handler expects. And then when there's a dependency that needs to be loaded, then I'll handle that accordingly and pass it to reflection-only load. And I'll also generate an object that I can see later to see what exactly what dependencies were not resolved. Next, I'll get an instance. Okay, let me set this up first. Okay. The next thing I'm going to do is I'm going to get access to that field. So I'm going to call the getField method and get that reflection only assembly resolve field, and I have to specify the binding field. So I'm asking for a non-public instance field, and then it'll give it back to me, and then I can set that value accordingly with my script block. So this is totally a hack, but it worked for me. Okay, now I'm going to try to load an assembly in a reflection-only context, and let's see what it gives me. Okay, so I was expecting this error. It said that it couldn't load one of its dependencies, the mono.csol assembly. And now, if because I've indirectly registered that event, I will get that event, and it prints out the missing dependency for me. So I don't know if you'll ever run into this when you're working on events, but it was a huge pain for me, so I figured I'd generate a workaround for it. I want to go back to some of the previous examples I gave on the different types of events. So here's a case where I'm using the WMI intrinsic event, and I'm going to generate a pop-up box every time you insert a USB stick. So let's try that out. And if everything works out, I should get a pop-up giving me the information about that USB stick. So that's kind of cool. This is kind of a contrived example, but I mean, hopefully you can see like some of the power in this. So you could use this to implement some pretty cool auditing. So like you could write this information to the event log, to a file, what have you. Now go ahead and get rid of that event. And move on to the next demo, where I'm going to register a WMI extrinsic event. And now I'm interested in module auditing. So whenever an exe or DLL is loaded into a process, I want to capture all that. And this time I'm going to log that to a file. And you'll see that I use the built-in event args variable pretty often. This is really handy when you register to an event. So when an event triggers, any information relevant to that event is populated in that built-in variable. And from that, in the case of the Win32 module load trace object, I'll be able to get the process ID, the base address of that module, and the name of the module itself. So let me go ahead and register that. And just to kickstart the process, I'll load calc. And then, so here, we're starting to log every single DLL that gets loaded into any process, which is kind of cool. It's going to generate a lot of noise, but I mean, this is really interesting information that, you know, if you have extremely strict auditing, you could leverage this to your advantage. Yes?
All these events are active only while your partial session is active, right?
Yes. Yeah, so if you wanted to persist these events beyond your PowerShell session, the only thing that I could think of that you could do is use permanent WMI event. Yep. Okay, next I'm going to show you how to use the engine events, and I'm interested in the onIdle event, so I'll go ahead and register that. So this should trigger every time I'm not doing anything in PowerShell. Okay. So let me give PowerShell something to do. I'll just throw it into an infinite loop. And now it's no longer idle. So. Let me just exit out of PowerShell now. Okay. And then here, I'm gonna trigger every 2 seconds with the timer.net object. Okay, cool. Unsubscribe. the next type of event is you can use delegates. So if a .NET object ever accepts a delegate, think of a delegate in PowerShell as a script block. So you can just assign a script block to that delegate, and every time that event triggers, then your script block is going to execute. So really common use for this, for me, is to use the server's certificate validation callback, which handles when invalid SSL certificates are present. More often than not, I just want to ignore that. So all I have to do is give it a script block with true inside to say, hey, anytime you run into an invalid cert, just ignore it and carry on. Because otherwise you wouldn't be able to download anything within PowerShell if you didn't do that, if there was a site with an invalid cert. So I'll show you what I mean by that. Okay, so I want to download content from one of my favorite sites, virusshare.com. They've got an invalid SSL cert. It's just a self-signed cert. So I want to be able to download from that. So let me just try to download some content. And it's not going to let me do that because it has an invalid SSL cert. So now let's just inspect this delegate here. Okay, so in the service point manager class, I am interested in the server certificate validation callback. And if you look at that delegate, it'll show you that the base type is indeed a multicast delegate. So we can tap into that and just give it our simple script block, which says just evaluate to true, which basically says ignore the invalid cert. And let's try to download that content again. Cool. All right. Okay, unmanaged callbacks. So if you have any experience interfacing with the Win32 API, there are certain functions that will take callback functions as a parameter. So it's a function that takes a function as a parameter. Well, it turns out you can actually bind a script block to that callback function. So an example is in user32.dll, there's the enum windows function, and that function accepts the enum windows proc callback function. I'm not going to get into all the details of how this works, but I wrote a blog post on how you can bind a script block to that. And lastly, there's .NET asynchronous callbacks. This is basically the managed or .NET equivalent of the unmanaged callbacks. So certain .NET methods can take other methods as parameters. And Oshin wrote a great blog post on how you can bind a script block to these asynchronous callbacks. And I use this technique pretty often, actually, on the job. When I'm reverse engineering malware, and that malware expects to talk to a command and control server, I like to stand up, I'll just whip together a script to emulate the command and control server, and I'll use this technique to implement a really basic web server. So let me show you that. Okay, so I should be listening on port 80 on the local host. Cool, all right. So all I did was I took Oshin's script where you provide the script block, and then it'll do all the binding for you. And then any method that takes that asynchronous callback, you feed it your script block, and you're good to go. Okay, so there's a ton of events available to you within PowerShell. So you either need to already know what they are or write a script to figure out which ones are available to you. So I wrote a few scripts to allow you to do that. First, I'm going to list out every single event in WMI. So the first thing I want to do in order to achieve that is I need to get every single WMI namespace. So I just wrote this simple helper function that gets that lists every single WMI namespace. Okay. Okay, so cool, that's working. And then from there, so I'll collect all my namespaces, and then within each namespace, I'll query all instances, all instances of meta class, and then that will list out every WMI object within that namespace, and then I'll see if that WMI event is, or if that WMI object is indeed an event. Takes a few seconds. And then what I'll do next, once I get every single event, is I'll break out intrinsic and extrinsic events. And the way I do that is for every event object, if its root object, like the object that it's derived from, is an extrinsic event, then it's an extrinsic event. If it's not an extrinsic event, then it's if it's not an extrinsic event, then it's an intrinsic event, and vice versa. Okay. Okay. So here are all the intrinsic events, and as I said, every WMI namespace is going to have the same intrinsic events. And then our extrinsic events are listed here. So there's actually some really cool events that you can tap into. There's a ton of really useful ones in root SymV2. So Win32 volume change events. You have your process start and stop trace. You can log when threads are started. Again, when DLLs are loaded or unloaded. I mean, you can really get creative here. So, like, if you want to do some really strict auditing, then I would consider checking these out to see what is already available to you that you can start tapping into. So here's the registry events. And so on and so forth. Cool. The next thing I'm going to do is I'm going to list all .NET objects that have events associated with them. And I need to use a little bit of reflection to do this. But what I'm doing here is I'm going to accept any .NET assembly, and then I'm going to do some type introspection on that. I'm going to look at every single type defined in that assembly. And I'm only interested in the public and instance classes within that assembly. And then I'll see if there are any events associated with that. And if so, then I'll pull out its name and the class that implements that event. So what I'm doing here is I'm getting every single assembly that's loaded into my current PowerShell process and passing it to getObject events to list out every event that would be available to you in your typical PowerShell session. So there's quite a few that you can tap into just right out of the box. Okay, so I'll talk about the limitations a little bit. You may have seen that in some of my examples, I was using write host a lot. You know, it's really ugly and clearly don't want to do that. But when you're executing within a script block in an event, there's not a whole lot that you can do with objects. So like I can't take an object and output it to my session. And the only write commandlet that you can use is write host. So write error, write verbose, out of the box, that doesn't work. But really, is there any good reason that you would want to do that? Sure, it would be nice if you could output objects within your script block when responding to an event. But I mean, events are, by nature asynchronous. So you could have events rolling in at any interval at any time, like well after you've executed your commandlet that taps into that event. Yes?
It's actually that it can happen in the middle of you executing a script.
Yep.
So if you're executing a script, this event can fire off and it will happen concurrently. Mm-hmm. And so if we wrote to error or output or anything else, we would be introducing that code in the middle of your script. That's why we don't do that.
Yep.
You can modify global variables.
Yes. Yep, exactly. So considering these limitations, which really are like positive limitations, what can we do to capture objects that get created while we're triggering an event? Okay, so we can log to a file. You saw I did that logging anytime a DLL was loaded into a process. As Jeffrey said, we can use global variables. We can use the event log. Say we're doing some sort of security auditing. We can have events that add content to the event log. We can use the event commandlets themselves to pull out data. And one of the things I like to do is if I'm packaging functionality in a module that uses eventing, then I'll have like a register commandlet, a get commandlet to pull out the information from that event, and then an unregister commandlet. So let's see that in action. Okay, so here I'm going to demonstrate some of the limitations of events in your PowerShell session. So what I'm going to try to do is every 4 seconds this event is going to trigger, and I'm going to try to output some stuff to the screen. So first I'm going to try to output date object from calling getDate, and then write verbose, write error, write output, write host, and let's see what I get. Something wrong here? Well, anyway, so the point I'm making here is that the only thing that would work in this instance is write host. That would be the only thing that's output to your current session.
Yeah. Back to the escape the call for date $, right?
Yeah. Here?
No,
Oh, yeah. Nice catch. Cool. Thanks. Okay. Okay. Unregister. Okay, so the only thing I get is the output from right host. Now, I can get a little bit more input or output, and again, this is kind of a hack. So if I want verbose output, I would just set verbose preference to continue in order to get that. And then if I really wanted like red error output, then I would have to use post to like write an error string literally to the output. So if you really want to do this, you can, but I don't recommend it. So let's try that again. Okay, so now we're getting the error output and the verbose output, but we're still not getting objects themselves output. Okay, so what can we do to alleviate some of these restrictions? Well, as Jeffrey said, we can use global variables, and so what I'll do here is unsubscribe from this event first. And again, I'm interested in whenever a module is loaded into a process, and I'm going to use global variables to track those. Oh, I need to be running elevated to do this. Okay. And the global variable I was using was global module loads. And so I get my objects output by using global variables. I'm personally not a big fan of using global variables. Just I think it's potentially dangerous. So there's other ways that you can get around this. What I'll show you here is one of the things I like to do again is use a register get and unregister commandlet. So the register to register to that event. And here I've written this tool. So I'm interested in auditing whenever a process gets loaded. So I have this register process module trace commandlet. And basically all it does is it'll register my WMI event. And then I have get process module trace, which just calls get event subscriber, and it'll pull out the objects that are emitted whenever those events are triggered. And then finally, if I want to unregister that, I just call this, which all it does is just call unregister event. So let's try that out. Register. Cool. All right, let's get a few modules loaded. Okay. There are all the DLLs that were loaded. And finally, we can unregister that. And we didn't use any global variables. So that's about it for me. Again, like these are all the ideas that I have for dealing with objects when you're triggering events. Do you guys have any ideas, like guys that use events in the job? Like, I mean, are there any other techniques that you can recommend? No.
Just to monitor changes for USB drivers, but
Oh, okay, cool.
yeah, I don't know, it's really just a proof of concept type thing. Never implemented it. Yeah, it's pretty cool.
So, like, what were you using to capture the objects that were generated?
Change drive event.
Oh, okay. All right, cool. Anything else?
Use wait events with the stop process to run start when it doesn't work so well.
Okay, you're using wait event? Yep. Okay, cool. All right. Anything
I
else?
always found persistence to be like I always set the
Yes.
But if it was something you wanted, kind of a long-term thing, it was always like, how do you best implement that? Do you hack together some kind of like scheduled task to just do long running, or something like that?
Yeah, dealing with persistent events beyond the execution of PowerShell.exe is a challenge. So yeah, you have scheduled tasks, permanent WMI events, a few other options, but yeah, it is kind of a pain. Yeah. Yes.
I did a lot of work with the Connect API within PowerShell,
cool.
And that thing, just because of the nature of the Connect, it's waiting for things to happen. All the code samples were all event-driven, and but I had so much trouble when the events triggered to make things happen in PowerShell that I eventually failed on all the events completely and found direct methods and stuff to run that. But it was definitely some interesting experience, all the different events you use with that API.
Yeah, when you have APIs with a lot of events, as you can probably see, like there's some acrobatics involved in capturing all the objects that get emitted when your event is triggered.
So what was the hardware? Was it just that it's kind of cumbersome programming model? Or?
Well, there was that, but just like once I got all the events set up, waiting for seeing gestures, hearing sounds, then it's like I wanted the results of that to be in the foreground of PowerShell, but then the events are not really in the foreground. So it always became this difficult exchange. The action blocks were so awesome, but then they never really gave me the kind of results I wanted, things to happen on the screen or whatever. So I ended up just failing on the events and just doing a polling loop directly against whatever the event was really triggered against. So it was fun rewriting the code twice.
You still have to go through the global variables, but if you set up a synchronized collection like a queue, you could monitor that from your main PowerShell, but then just have the events operate that.
Yeah, I don't think I knew about the global variable thing. So that might have changed around the way I done it. I might have had a polling loop against the global variable.
Yeah, that's probably the easiest way to do it is with global variables.
When you are doing global variables, do you have to worry about concurrent access? So you need to use like a synchronized collection?
Cool. Well, that's all I got. I mean, the events can be extremely powerful in PowerShell. There's so many things that you can potentially tap into, like especially in WMI. Like there's so much information just readily accessible for you to tap into. So like especially if you're involved in security and you're on the defensive side and you want to implement some pretty strict auditing, you've got everything available to you. Like you just need to tap into it. So, that's all I got. Thanks.